So far, we've been using the direct truth table method. That is, we've been filling out an entire truth table in order to evaluate the validity of an argument. In this video, I'm going to show you both methods, and my hope is to show you the connection that both the direct and the indirect methods will both do the work in evaluating whether an argument is valid or not, but they do it in different ways. And in some cases, the indirect truth table method is going to be a more efficient way of doing that. So I'm going to move through this direct truth table pretty quickly, and then I'm going to push it to the side, and then I'm going to demonstrate the indirect method. So here we have our argument. This is our first premise, if R then S. The first premise is separated from the second premise by the slash mark here. Second premise is the negated R, or it's not the case of R. And then the two slash lines indicate that the conclusion is coming up, which is the negation of S, or it's not the case that S. So on our left side, just like always, we have our two statements of the argument, and then we have through rows 1 through 4, all the possible truth value combinations for those individual statements. So we should know that when we go through the direct method, we're going to use the rules that are associated with each statement. So our first statement is a conditional, so we use the rules that we know for the conditional, and the conditional is true in all cases except for when the antecedent is true and the consequent false. So those are the truth values for the first premise. The second premise is just the negation of R, and we just will work through this line by line. So if R is true on row 1, the negation of R is false. So we just go down the line. If R is true, and the negation of R is false. And then for 3 and 4, R is false, so the negation of R is true. Now remember, the truth value for any negated statement is the negation, right? It's not R, so it's the negation. That's why we're putting the truth values underneath the tilde. And we're going to work the conclusion the same way. We'll just go row by row. So row 1, S is true, so the negation of S is false. Row 2, S is false, so the negation of S is true. Row 3, S is true, so the negation of S is false. And row 4, where S is false, the negation of false is true. Okay, so we've completed our truth table, and now we're looking for any instance of where all the premises are true and the conclusion false. So we can look at row 1. Well, we don't have both premises are true, so it can't be invalid on that row. Same thing with row 2, false, false, true. But row 3, this is exactly what we're looking for that would indicate that this argument is invalid. What this row says is that under the conditions of R being false and S being true, it's possible for this conclusion to have all true premises and a false conclusion. So this argument is invalid. All we need is one row, that is one possible way in which this argument can have all true premises and a false conclusion. And the direct truth table is how we determine that, how we prove that to be the case. Okay, let's move this up here. Now let's use the indirect truth table method. I'll lay out the argument below, and then I'll explain how to go about using the indirect method. Okay, so up here, we did the direct truth table method, and down here, we're going to use the indirect truth table method. The basic idea with the indirect truth table method is we're going to assume the argument invalid and then see if we can consistently apply the truth values such that it looks like true premises and a false conclusion. Okay, so we're going to start with the assumption that this argument is invalid and then plug in the truth values. And if we can consistently apply the same truth values for that letters, assuming it's invalid, then the argument is invalid. Since this is the same argument, we should come up with the same evaluation of it. In other words, if we start by assuming that the argument is valid and we're able to consistently apply the truth values for each simple statement, we're going to find out that we can do that, which shows that our assumption of invalidity is correct and the argument is invalid. So let's start by assuming the conclusion is false. What's our conclusion? Our conclusion is the negation of S or tilde S. So let's put an F underneath that tilde. If the negation of S is false, we know that S must be true, right? So S is true. Now let's work backwards. Let's make tilde R true because we want both of these premises to be true. So if the tilde R is true, then we know that R has to be false. So R is going to be false. And all I'm doing here is I'm just keeping track of my truth values, right? Because they're locked in. Once I start with the assumption that this is an invalid argument, I'm locked into S being true because the conclusion is false and the conclusion is tilde S. So now I'm locked into R being false because for this whole premise, tilde R to be true, R has to be false. Now we're down to premise one here, and we're locked into our truth values. So let's see if this will work. Well, if we're locked in for S being true and R being false, we know the rule of the conditional is that the conditional is only false when the antecedent is true and the consequent false, although all other times it's true. There we have it. All true premises and a false conclusion. So we could consistently apply the truth values for R and S, assuming that the argument has an invalid form. Now look at what we've done here and notice the relationship between the indirect and the direct. We showed that in the direct truth table, we found that this argument can have all true premises and a false conclusion when R is false and S is true. Well, that's exactly what we found here. S is true, R is false, and those are able to be consistently applied. Now, let's do an indirect method for an argument that's valid. Okay, so I've switched the argument up a little bit. I've turned it into what's called a modus ponens. So you'll recognize the difference here. It's not negated R, negated S. It's just R then S. So the argument is, if R then S, then the second premise is R, and the conclusion is S. So this is a valid argument. You'll encounter this a ton of times in the class. But let's just show through the direct method here that it is indeed valid. So we can keep the conditional the same. We did our work here, so we don't need to reproduce that. So let's just fill in the second premise and the conclusion. So here we're just taking the values of R for each of the rows and plugging it in here because it's the second premise is just R. So we just reproduce that. So in row 1, under premise 2, R is true. Row 2, R is true. Row 3 and 4, R is false. And then we'll do the same for our conclusion S. We're just going to plug in these truth values row by row. So in row 1, S is true. Row 2, S is false. Row 3, S is true. Row 4, S is false. What we notice here is we have no row with all true premises and a false conclusion. That means that it's not possible for this conclusion to have all true premises and a false conclusion. And since we've included all possible combinations of truth value for the individual statements, we know that we've covered all possibilities. It's not possible for this argument to have all true premises and a false conclusion, so we know it's valid. Now, let's do this. Let's evaluate the same argument using the indirect truth table method. There we go. So again, we start with the assumption that the argument is invalid, and then we see if we can consistently apply those truth values across the entire argument. Now, since we already know that this is a valid argument, we shouldn't be able to do that. So this is really going to demonstrate what it means for it to not be able to have consistent truth values on the assumption that the argument is invalid. So to start, we need to assume the conclusion false, because that is what's needed for an invalid argument. Remember, it would need to have all true premises and a false conclusion. So S is locked in as false. Now, both premises would need to be true for this argument to be invalid. So R would need to be true. So R is locked in as true. So now we need to see if we can apply those same truth values for R and S to the conditional. So here we're locked in with R being true, but S is false, which means there's no way that this argument can have all true premises and a false conclusion, because it would at least have to have the conclusion false and this premise true. But with those truth values, we can't make premise 1 true and premise 2 true and the conclusion false. With those truth values, premise 1 ends up being false. So what would make premise 1 true? Well, the only way premise 1 could be true and premise 2 could be true is if S is true. But notice here we have S true and S false. That's the inconsistency. We cannot consistently apply the truth values, starting with the assumption that the argument is invalid. We can't consistently apply the truth values for S and R such that we could make the argument have all true premises and a false conclusion. The only way we could do that is for F to be both false and true, which shows that cannot consistently apply the truth values to make this an invalid argument.